And 3. So, friends, welcome. Friends. Today we're talking about standard deviation, which is very similar to mean deviation. Hey, friend, listen up, friend. Yeah, you. You.
In the back?
On the internet. In the back. Yeah, I'm looking at you. You with a face. Standard deviation is similar to mean deviation. All right? They both measure variability in a data set. Standard deviation, though, is always going to be a smaller number, and it comes from this concept. I guess I could say recall, perhaps, but this isn't as much of a recall concept as. So it turns out absolute value in some textbooks is defined as this. And could someone explain to me why that would make sense?
X is positive, it's going to be positive, so you simplify the square root with a 2 over there, and the square roots always have to be positive.
Right, so whether x is positive or negative, squaring it will make it positive, and then square rooting it will bring its magnitude back down to its original size, but it'll be positive. All right, so that's kind of the concept that shows up within standard deviation. So standard deviation, and there are actually some variations of this formula. Nope. Deviation? Nope.
Dova.
Deviation. Yeah. Standard Dovahkiin. I think we use, lowercase sigma. All right.
Is that like an O with like a...
I don't know. It's like a...
Or a pair.
Like that.
I think they're learning this in math right now.
Yeah, I did hear them talking about it the other day. Indeed they are. So standard deviation, instead of an absolute value showing up, there's going to be the square root of a square showing up, except the square root happens to be over the entire thing. So it'll be the square root of 1 over n times the sum of I equals 1 to n of xi minus x bar squared. All right. So standard deviation, this technically would have been exactly equivalent to mean deviation if the square root was not here but ended right there. Okay, that would be equivalent to mean deviation. Standard deviation, the square root goes over this whole thing. So we end up square rooting our answer. Ooh, wait a minute. Or would standard deviation be larger?
Or would it be smaller?
Boy, we'll have to do some side-by-side comparisons. But I'm pretty sure one is always larger, one is always smaller. I have to think about 1 over n. I'll put square rooting at the end.
I think it's going to be smaller.
But anyways, so this is the idea of standard deviation, and as I said, this is a lowercase sigma. All right? So sigma. It kind of, I guess, looks a little similar to like a cursive S-ish. I don't know, if you wanted to pretend. It's kind of like if you take the letter P and then mirrored it, and then rotated it.
Oh, would you look at that?
Maybe? I don't know. But it's more curvy. It doesn't have like a sharp corner up here.
Or maybe it's like a pear.
Yeah, I like the pear. I like that. Sigma. So there's standard deviation. So let's talk about how we could calculate this. You guys want me to do them by hand, or do you want me to just jump right into Excel? Excel?
Both.
Yeah, let's just jump right into Excel. So this is the idea. So here's what we got going.
Want to get rid of all those numbers?
So standard deviation, instead of absolute valuing the xi minus x bar, let me reveal. I'm going to square xi minus x bar.
Why did you just add that?
Because we're going to add on to our formula. So this spreadsheet is going to calculate for us both mean deviation and standard deviation. So what would this formula be?
Equals average.
Equals, what cell am I squaring here?
The x bar. The xi x bar.
Xi minus x bar, and I'm squaring it, which I can use the caret to the second, or I could just multiply it by itself like that. I'll use the square thing here. And now squaring it is going to make it positive, as our friend said earlier, right? And then I would drag that down technically. In my case, I've already pre-programmed some conditional formatting. I'm going to actually reveal what I've already typed in here. Bam.
Wow. Really? Why can't you just do it by hand?
So all of these, notice, it's just taking this and squaring it. It's got some formatting saying, like, if this is blank, then just keep it blank. So that way I don't have a whole bunch of numbers down here when I don't have a piece of data over there. So let's see. So according to the formula, I square that difference, and then sigma tells me to add them up. So that's what I did here. This is the sum of that column. So that's what we've got.
How do you know Excel didn't screw up somewhere and that's just not the right answer?
Because I trust Excel. Unless I'm the one that screwed it up.
I heard there's a rumor that in one of the infinite cells, there's a cell that says Bill Gates in it.
Yeah, I'd heard that rumor before as well. I mean, I don't think there's technically infinitely many cells. But yeah, like if you imagine if you go down like 6,242 rows and then over like 379 columns, like if there's just like one cell that says Bill Gates. Like, what's up, Bill? Or like his picture. Like, that'd be awesome. It'd be pretty great. And actually, yeah, that's in terms of copywriting your spreadsheets. Like, if you were worried about someone stealing your work or something, you could just, like I did, I have stuff hidden in font color white here. So you could hide it in a cell that only you know. Like, maybe you could like scroll over to like your initials and then like go down to like your age and like hide a cell there with your name in font color white.
Couldn't you just highlight the whole thing and change the color, and then it would just pop up?
They could, but then they'd still have to they'd have to scroll over to the right spot. So standard deviation. What's my formula for standard deviation going to be? That looks broken. What I'm going to do is take this sum
And add it.
and what am I doing? Not yet.
Adding.
Subtracting X bar.
No, I already got that. So far I've got this much calculated. I'm multiplying it or dividing by n, right? So I'm going to take this number, divide by n, and then square root it. Okay? So let me actually reveal. There we go. So what do I've got? I've got square root, squirt, right? Is the Squirtle. Is the square root function in Excel. So I'm square rooting this sum and dividing by the count. So that is the standard deviation formula. All right, and let's look. Let's compare it to mean deviation. Okay, standard deviation is bigger than mean deviation. My bad. I was wrong earlier.
I told you it was bigger.
Yeah. So, and it turns out Excel actually can calculate standard deviation.
So equals standard deviation.
Yeah, not quite. And there's actually two standard deviation formulas in Excel. This is STDEV P. The P stands for population. There's a different formula depending on whether or not you know the size of the data list that you have. All right. So the formula we learned is if you know the size of the list, like if you know how many numbers are in it. Then there's a different one, which is if you don't know how many numbers are in the list. If it's some unknown population size, I believe the difference is I would divide by n plus 1 is what I'd end up dividing by. Nope, apparently not. Yeah, technically you already have it, I believe. Yeah, you just have to... You have to change the font color. Or is it n-1? I'm trying to remember. Well, there it is, yeah. So it's just n-1.
So if we change the font color, those things will pop up?
Yeah, they were hiding there the whole
So
time.
basically, I'm going to highlight the whole entire thing, and then I'm just going to be able to...
Right, yeah. So Excel does have two standard deviation formulas. One has this P in it, and the other does not. I don't remember, does Excel have a... Oh, it's font size white. Come on. All right, can I type here? Equals median m duration. Wow. D term. I don't even know what these are. So yeah, I don't think now mean deviation actually doesn't occur as frequently within the world of statistics. Standard deviation is of course standardized in the world of statistics. It's the more frequently used one. And we'll end up doing all sorts of kind of data analysis based off of standard deviations later on in this section. But that's the idea for standard deviation. Questions, comments?
Concerns.
Observations?
No.
Do it out by hand? Okay. Yep, so let's interpret the same formula by hand. So let's do an example of a very short list.
Let's go 4, 5, 10, and 9.
4, 5, 10, and 9. A little out of order there. I like what you did. So what do? We find the average of these numbers. So let's see, 9 and 9, 18, 28 divided by 2. X bar is, what's 28 divided by 2? 14? X bar is 14. Let's see, so then I'll have xi here, which is 4, 5, 9, and 10. Yeah, add them all up divided by... Wait, I divided by 2. I should divide by 4. Thank you. Good catch. Man.
Son of a
7.
donkey.
Settle down there, friend. This is now on the internet. You can't say stuff like that on the internet. So, anyways, excuse me, friend.
I'm not swearing though.
Come on. So there's x bar. So what's the formula tell us to do? Subtract x bar from xi. So we'll do xi minus x bar. 4 minus 7 is negative 3. 5 minus 7 is negative 2. 9 minus 7 is positive 2. 10 minus 7 is positive 3. You chose some really nice numbers there, friend.
Oh, you're welcome. Friend.
Okay? So you actually just have to do this up by hand. Next thing I'm going to do is what, according to this formula? Square those values. Roll that beautiful bean footage. Negative 3 squared is 9. Negative 2 squared is 4. 2 squared is 4. 3 squared is 9. Now what do?
Oh my god.
Find the sum. Add them up. 15 and 15. Nope.
Oh, no,
13 and 13. What? This adds up to 26. And then I multiply by 1 over n. N is 4. There's 4 terms, right? So, or I divide by 4, whichever you want to think about it. So I would do, let's see, I guess I'll just call this 26 divided by 4. So what's that going to be, 6.5? And then how do I find the standard deviation? What's the last thing I do?
Square root it.
Root? I was going to say root it, but it's just one root. So square root 6.5, and I would get 2.5495, roughly. So the standard deviation in this case, so our mean is 7, and on average my numbers are 2.5495 away from it, right? Because, I mean, look how far. This one was 3 away, this one was 2 away, this one's 2 away, 3 away.
So how do you get the 2.5? Just adding all the 6.5?
I'm square rooting the 6.5 is how that comes.
I don't know where this 26 came from.
The 26 was the sum of these. That's what the sigma means. Sigma means add up all of these. All right, so it's adding a list is what we got.
So I just like disregard the N and the I.
Right, that just means start with your first term and all the way to your fourth term, Adam.
So on the quiz, it's just going to be like you can use Excel and
You should know formulas and how to do it by hand too, right? Yeah, you should know how to do it both ways. So the last thing we're doing today is now. Turns out we can also find standard deviation in a frequency distribution. So let's talk about that.
Too many to count.
So standard deviation in a frequency distribution. Now, similarly to mean in a frequency distribution, I don't know the actual data values. I do know how many are in each class. So we will assume that all of the data values in each of those classes, on average, is equal to the class mark. All right? So that's going to be kind of like the presumption here. So I can get an estimate of the standard deviation in a frequency distribution. And that is going to be this big, ugly formula.
I don't
The
like
square root of the sum
Square root
of I
theta,
equals
theta.
1 to k, I believe, right? We use k's on these, where k is the
I
number of classes.
minus 1k.
And we will do our xi minus x bar.
Xi minus x bar.
So that's the mean in a frequency distribution. So this alone is already an approximation. And I'm squaring it, similar to standard deviation,
Squared.
multiplied by the frequency of each class.
Multiplied by this frequency. That's it?
Nope. And this is still under the square root. Then in the denominator, I find the sum of
Beta kappa theta.
the frequencies. Let me just make very clear that this square root symbol goes all the way down.
Why?
So that way we know that it's a square root after I do the division rather than before. Right?
No.
And I might as well extend this vinculum over here.
Now it looks so bad. Look, I had to extend.
And
Thanks,
just to define these variables, xi in this case is not a data point. What is xi in a frequency distribution? Do you remember? That is our class
Right.
mark. Fi is a frequency of a particular class. X bar is our approximated mean. Okay? And k, I guess I might as well say, is the nombre de classes.
Classes.
Right? So let's see if we can go back to our original mean deviation frequency distribution stuff and add standard deviation to it.
Wait, can I write this down first?
Yes, certainly. You can just pause the video right now. Finish writing.
A video. What are you talking about?
The video we're all in right now. We're filming it live, but maybe in the future you will go and watch it and finish writing
And teach
it
your
down.
kids.
Yeah.
Say, this was my math teacher's video.
Ooh, what is it?
I think that when I die, I'll want all of my videos played at my funeral. All of them. It'd be a really long funeral. But it will also have like the videos of when I fell on a river kayaking in the winter. It'd be pretty good.
You also need, but no, I think you have to have people go.
Ouch,
all
hurting my
your
cup.
one-liners and just put them on one video.
Yeah, Wadi quotes could be officially read by individuals that run Wadi quotes, whose names I wouldn't say on the internet.
Jordan Labate.
The dude! That was a made-up name, internet. So,
Joel Gonzalez.
man, those are like such made-up names if I've ever heard any. So anyways, so guys, let's go to frequency distribution. So this is the... Anyways, gentlemen, please. So here's our frequency distribution work that we'd already done. We figured out how to calculate the mean in a frequency distribution.
All in one?
Yeah, it was all there the whole time. And actually, I guess that's already calculating there, so I'll just walk us through it. So we already figured out how to find the mean of a frequency distribution. The way we did that was I multiplied the class mark by the frequency. That gave us kind of what we expected the total value of all of these numbers was, the sum of the numbers in that class. And then we added them all up. So we expect that this is the sum of all of our numbers. And then we divided by the sum of the frequencies. All right? Yes. Right? Yeah. Yes. Okay. I was worried there for a minute. So that's how we approximated our mean. In this case, I actually have the real mean because I have an actual list of data here. So the real mean is 32 in this case. Our approximated one was 32.6. So that's not bad. Although it would shift depending on what my intervals were. So yeah, it's a little bit different depending on how I break it all up. So, so according to this formula, I'm going to take my class marks and subtract the mean. Okay, so let's do this one at a time. So here's class mark, subtract the mean. All right, so class mark was 29. Subtract 32 point blah, 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 and I get blah, blah, blah. All right?
What you go
33 minus, sneezes.
Negative 3.6363636.
Right? So I subtract the mean from all of the class marks, is what we ended up getting. Now the next thing in this formula, it tells me to square those, right? Square them. So this formula is just that cell squared, and I do that. That gives me positive values, only positive because squaring a negative gives me a positive. Then, after I square them, I multiply by the frequency. So I did. So I took these squared, and I multiplied by how many there were. All right. So 105.7, 1.19, etc. And now that I've calculated that, now I'm finally at the point where I'm calculating the sum. I can't, man, without using my pen, I can't draw straight lines having to use a mouse pad. So I add them up, and I get 253.09091. Probably 09 repeating, I'm guessing. And now what do I have to figure out? What's this tell me to calculate?
God, that's so
What's that denominator? So the sum of the frequencies, hey, I already calculated that for mean. So I'm going to take this sum and divide by 22, right? And after I do that, the very last thing I do is square root it. So that's why this formula I have is the square root of this sum divided by that sum. All right, so it's just a matter of kind of order of operations, like walking your way through that whole process.
No? Pandora.
And notice, in this case, the standard deviation, once again, is larger than the mean. Well, actually, that's just mean. That's not mean deviation. So we never end up calculating the mean deviation in a frequency distribution, just the standard deviation. And that's able to give us an estimate based off of that. And actually, what is the for real standard deviation in this list? Let's see.
You keep typing in the right, dude.
Yeah, let me see what I got. Is anything written over here? Let's see. Select the column before I deleted the contents of the cell. Bum bum. So in this case, I actually was able to calculate the for real standard deviation of this list, and you can see that it's pretty close, right? So it's an estimate because that was based off of class marks versus the real data. Who knows what else I wrote in these cells? Nothing, I guess. Oh, that's the end of it.
No, I highly doubt that.
I should next time just like have a hidden thing that when I reveal it says, "That was an amazing video, Mr. Waddy." I'd be like, "Thanks, past Mr. Waddy." Like it was there the whole time. You'd be like, "What? He pre-planned that?"
It's like in the past. You like plan something and for someone else in the future.
Get it?
Hmm.
So,
Yeah.
Time capsule?
Yeah. So, anyways, so that's measures of variability. All right. So it measures the dispersity of our data, not the center of our data, but how spread out it is. And the larger our standard deviation is, the more diverse or dispersed my numbers would be. All right. So I think we're pretty good with standard deviation. Excellent, excellent. Bye-bye, everybody. Goodbye, Internet. And those were all fake names that were made up to protect the innocent.